In this video, I'll talk about backup and restore with Amazon Web Services. Cloud Native Backup deals with backing up cloud data to the cloud. For example, we could take EBS volume snapshots, which are stored in the cloud already, and back them up to S3, which is Amazon Web Services Cloud File and Object Storage Solution, which could then be replicated between different locations. Amazon Machine Images, or AMIs, are essentially templates that are used to build new virtual machine instances. They, too, can be replicated. That might be required if we've customized AMIs. In some cases, backups can also be file system dependent. For example, if we are using backup agents within an operating system running in a virtual machine. Multi-volume backup is also possible via LVM, Logical Volume Management. LVM is used primarily in Linux operating systems, whereby multiple physical disks get treated as a logical unit. We can also deal with database backup in the cloud using native tools that are built in to the RDBMS, the Relational Database Management System. Whether we're using MySQL or Microsoft SQL, Oracle, and so on. So we could use backup tools either in the GUI, at the command line, or in some cases through API calls if the vendor supports it. We can also use native database replication that might be built into products like Oracle and Microsoft SQL Server. For database backups, we can also back up at the volume level where the database itself is being stored. We might look at volume snapshots, for instance, to serve that purpose. We can also automate backups using RDS in Amazon Web Services. Database snapshots take a snapshot of the state of the database instance as opposed to the entire disk volume on which it is hosted. When it comes to an on-premises customer network, we have the option of backing up our Amazon Web Services configuration and data to an on-premises system. S3 and Glacier have APIs where we can programmatically control backup or retrieval of data from S3, as well as archiving in Glacier. The great thing about APIs is we can build those into existing applications we might already be using. Various vendors will have solutions for backup, either to on-premises or from on-premises to the cloud, as well as API solutions. Alternatively, we might consider the use of the Amazon Web Services Storage Gateway. The Storage Gateway is a virtual machine appliance that we would run on premises on our network, whereby we could have a copy of frequently used data available locally on premises that gets replicated to the cloud. This way, the data is close to the devices on that on-premises network, which might be required. Then we could also look to a hybrid backup solution. For example, we might utilize Amazon Web Services Direct Connect. This can link Amazon Web Services and a customer data center or on-premises network. AWS Direct Connect allows for a private, dedicated network link from the customer directly to Amazon Web Services without going through the internet. As you might have guessed, this is going to be more expensive than your standard high-speed link through the internet, and it might not be available in some regions. There are partners that have partnered with Amazon Web Services to make this possible. Our storage media, as well as our backup configuration, could be running on servers which run within EC2 virtual machine instances. A storage gateway running on premises is an example of this. It's very important that when we deal with backups, we think about protecting the configurations of servers. It's not necessarily crucial to back up server operating systems because that's easily replaceable. That's not to say that we can't do that, but it's crucial that we have the configuration backed up. It's very easy to install an operating system from an AMI or from a DVD ISO image, but it takes much longer to get to a specific configuration point. We should also use the appropriate data storage. For example, in Amazon Web Services, S3 is highly durable and is really well suited for most purposes. We should also consider the use of automation for backup, whether we are using backup software that we might manually install ourselves into virtual machine instances. We can also automate some Amazon Web Services configuration where after data is a certain number of days old, it will automatically be archived in Glacier. We could also look to command line interface solutions as well as API, application programming interface solutions for backup. Most Amazon Web Services have associated APIs so that developers can programmatically access aspects of those web services, including backup. Here in the S3 Management Console, I can see I have a single S3 bucket called e-commerce logs quick DL72. Having that bucket selected over on the right, I can click on the Properties button to view some of the configuration options available. One of the options is under Lifecycle. Here I can manage the lifecycle of objects and files stored in this S3 bucket in the cloud. And if I click the Add Rule link, here I can apply a rule to specific items like folders within the bucket or the entire bucket. When I go through the Configure Rule wizard, I can then determine when to automatically archive objects to Glacier, a specified number of days after the object is created. Notice I also have the option to permanently delete. So we have ways that we can automate things like backup and archiving depending upon the cloud service. Now, if you need full flexibility, you should really think about looking at the APIs, the application programming interfaces, where you can really pretty much do whatever you want to automate many aspects of Amazon Web Services. If I cancel out of there, notice also in this S3 bucket, I can configure cross-region replication. Maybe that's part of my backup strategy to make sure that I have a copy of data stored elsewhere in other regions. So for this, I would go through the wizard to enable versioning to configure cross-region replication. In this video, we discussed backup and restore with Amazon Web Services.